Our star, a timeless wonder, the Sun, a blazing ball of plasma that has illuminated our skies for billions of years. It is a symbol of power, warmth, and life itself. This celestial giant holds our solar system together and makes life on Earth possible. But how much do we really know about this star we call our own? This is a journey to understand the Sun, from its birth to its eventual demise. We'll explore its incredible size and power, unravel the mysteries of its fiery heart, and learn how it influences our planet and the solar system. Get ready to be amazed by the wonders of our very own star. The Sun is a constant presence in our lives, yet it remains a mysterious object in many ways. Its sheer distance from Earth makes it a challenge to study, but scientists have made incredible strides in understanding this celestial wonder. One of the most fundamental questions about the Sun is its age. How long has it been burning brightly in the sky? Astronomers estimate the Sun to be around 4.6 billion years old. That means it was born shortly after the universe itself came into existence. Another key aspect is the Sun's distance from Earth. It sits at an average distance of 93 million miles, or 150 million kilometers, from our planet. This vast distance, known as an astronomical unit, or AU, is a fundamental unit of measurement in astronomy. Understanding the Sun's age and distance is just the beginning. In the next section, we'll delve into its incredible size and mass, revealing just how colossal our star truly is. The Sun is truly a giant among stars. Its diameter is a staggering 865,000 miles, or 1.39 million kilometers, making it roughly 109 times wider than Earth. To put that into perspective, you could fit over 1 million Earths inside the Sun. But size isn't everything. The Sun's mass is even more impressive. It contains a mind-boggling 99.86% of the total mass of our entire solar system. That means all the planets, moons, asteroids, and comets combined make up a tiny fraction of the Sun's total mass. The Sun's immense size and mass are responsible for its incredible gravitational pull, which holds all the planets in our solar system in orbit. It's like an invisible hand guiding the celestial dance of our planetary neighborhood. Now that we've grasped the Sun's sheer scale, let's turn our attention to the heart of the matter, its scorching temperature and fascinating composition. Section 4. The Sun's fiery heart. The Sun is a giant ball of plasma, a state of matter where electrons are stripped from atoms, creating a superheated mixture of charged particles. At its core, the Sun reaches temperatures of around 27 million degrees Fahrenheit, or 15 million degrees Celsius. This intense heat is generated by nuclear fusion, a process where hydrogen atoms are forced together under immense pressure, fusing to form helium and releasing enormous amounts of energy. The Sun's core is like a giant nuclear reactor, constantly churning out energy that radiates outward. The energy produced in the Sun's core takes a long journey to reach the surface. It travels through the radiative zone, where photons of light are constantly absorbed and re-emitted, and then through the convective zone, where hot plasma rises and cooler plasma sinks, creating a churning effect. The Sun's composition is also fascinating. It's primarily made up of hydrogen, about 70.6%, and helium, about 27.4%, with trace amounts of other elements like oxygen, carbon, neon, and iron. Section 5. The life cycle of a star. Like all stars, our Sun has a life cycle. It wasn't always the bright, shining star we know today, and it won't stay that way forever. Astronomers estimate that the Sun is roughly halfway through its main sequence lifetime, which is expected to last for about 10 billion years. The Sun formed from a giant rotating cloud of gas and dust known as a solar nebula. As the nebula collapsed under its own gravity, it began to spin faster and heat up, eventually igniting nuclear fusion in its core. Once a star ignites nuclear fusion, it enters the main sequence, a long, stable period where it fuses hydrogen into helium in its core. Our Sun is currently in this phase. However, the Sun's supply of hydrogen isn't infinite. In about 5 billion years, it will exhaust the hydrogen in its core and begin to fuse helium. This will cause the Sun to expand significantly, transforming it into a red giant. As a red giant, the Sun will engulf the inner planets, including Earth. Eventually, it will shed its outer layers, leaving behind a dense, hot core known as a white dwarf. This white dwarf will slowly cool over trillions of years, eventually fading into a black dwarf.